Welcome back, and today's video we are going to solve another LeetCode problem, which is the valid anagram. So if we go to the Google Chrome here, this is the problem, the valid anagram. So basically, given we are going to have like two strings, the first one and the second one, and we should return to if it is anagram. And if it is not anagram, then we need to return the false. And what is an anagram is, based on its definition, it's a word or phrase formed by rearranging the letter or of a different word or phrase, typically using all the original letters exactly once. So for example, if this is the word and this is the second word, if the composition is the same, then it is an anagram. For example, this one does not have the same letter as that one, so it is basically not an anagram. So we can solve it in TDD again, and let's go in the Xcode. So I'm gonna open my Xcode and let's create a new project here. Let's create a macOS framework and let's name it the project Valid Anagram. Okay, make sure we check the test and let's hit next and save it somewhere. Okay, so we already have the project here, so let's make sure that my project is actually good to go by making test is failing for now. So let's make test fail, Command U. Okay, the test is failing, which is pretty good. So the next thing that we can do is copy paste the problem here, because we want to reuse this in Xcode. So let's copy and paste around here, right? And what else we can do? We basically can start to code. So task, for example, is anagram. That function returns false. We can start on a very minimum approach that we can do. For example, return false on both strings are empty here. Right, basically we want to make sure that it is false when the strings are empty. So let's create the SUT, which is the solution here, and let's call the anagram function SUT.isAnagram with the result of empty on both string, and we are expecting that our result is false. Right. So let's Command U, and I'm pretty sure that we cannot run the test because it's forced us to have the return statement here, which is returning false at the moment. Okay, great. So now we can commit. Is anagram returns false on both strings are empty. Okay, so let's move to another case. So what is another case? Return false on, for example, returns false on first strings is empty here. So the setup is pretty much the same. We still need the SUT and we need the result with non-empty string here, and I believe we need to return false as well, and Command U. So the test is passing, which is pretty good, but actually the logic is not, kind of silly, but we can evolve the logic later when we find the right time. So let's comment here. Is anagram returns false on the first string is empty. And I'm gonna fix the typo here. Run this again. Okay, still passing. So let's commit. Okay, what else we can do? We can try to cover the non-empty string on the second string only. So we could copy paste the setup, and we need to rename returns false on second string is empty. So we need to make first string is empty, and we need to like make a non-empty string on the second string. So let's hit Command U again. Okay, we have the passing test. Pretty good. Let's commit. Is anagram function returns false on second string is empty. Hit commit. So now I believe we can have like a test if the count of the string is not the same. It means that the composition is different, right? So let's check is anagram returns false on different strings count here. So the setup is again the same. We need the SUT, and then we need the result here. For example, the first string is, the count is, for example, A, B, C, and this one is only A. It means that the count is not the same. And let's return false again and hit Command U, and let's see. Great, we are covering this scenario. So let's commit. Is anagram returns false on different strings count. So what else we can do right now? We can check whether actually I have typo here. Let's fix this. Fix typo. So now what we can do, we actually can check whether both texts are actually anagram or not. So let's create a function. Test is anagram returns false on not anagram, for example. So we have the solution here, and what is the not anagram things? I think we can like I think this one is not anagram, right? Or we can like bring the example from the LeetCode itself, which is the rat and car. So this is rat and car here, and I believe it should return false here. And let's run the test, and of course the test is going to be passed because we are falsely returned false here. So let's commit again. Is anagram returns false on not anagram, and let's commit again. And now we can like check whether it is actually true on anagram. So we can like create a function. Is anagram returns true on anagram words. So let's copy paste the solution here, and let's invoke the anagram function, which is the, I believe this one, anagram and nagaram. Okay, and I believe this should return true. Result is equal to true here. So let's run the test, and hopefully we can see the failing test. And of course, because we are expecting true here, but we are forcing it to return false. So how to like compare the real string and compare those two strings? So one way to do that is actually comparing the composition of that string. So for example, we have this kind of anagram, right? This one, and nagaram here. So the letters are scrambled around, it is shuffled around, but the composition is the same. So for example, A is 3 here, and G is 1, and R is 1 as well, and M is 1, and N is 1. And if we are having another example, for example, the rat and car here, rat and car, so both A are 1, both R are 1, but the C and the T is not the same. So this is not anagram and this one is anagram. So we could like compare that. So how to like comparing those composition? Well, actually we can compare using the hash table. So we need to get the hash table for both string and compare the hash table, right? If we create the hash table, for example, we basically store the r is equal to 1 and a is equal to 1 and t is equal to 1. And the second hash table for this one, car, is actually c a r. So we already got the hash table, and if those hash table is not the same, it means that it is not anagram. But for example, if I have car and rack here, RAC, it means that it is anagram because we have like single C and single A and single R. So that's how we can like solve it. So let's code that. First, we need like create the first hash table. So for every single character in the first string, if I can get the count for the hash table or first hash table at that character, well, basically it is saying that if that character on the first hash table is actually exists. If it exists, then what we want to do is increment the counter at that character. So count is +1, and if it is not exist yet in the hash table, then we can increment or assign 1 for that corresponding character, right? So basically we need the hash table of a character to int, because this is the character and this is the count, right? Of course, we need to create the second hash table. So let me create real quick here. So for every single character in the second string, which is the T, and of course we need to change this, hit Control and Shift and click, and this one should be on the second hash table, right? So for every single character in the second string, if we can find that character on that hash table, it means that we increment the counter for that character. Otherwise, we need just to assign that into 1. And let's create the second hash table here, right? We already have the hash table, so we could like compare. For example, if the first hash table is actually equal to the second hash table, it means that it is an anagram, so we can return true. Otherwise, it is not an anagram. There. So let's hit Command U and let's see. We should have like true here. Okay, great. We are passing in this test, but somehow we are failing on this test. Why? Because it is actually comparing the same empty string here. And I believe we could like handle these edge cases here. So if it is empty, we should return false. Why is that? So by definition, an anagram is a word or phrase. So we should have a word, not an empty string. So we could handle that. So we could check if S or the first string is empty and second string is empty. It means that it is not an anagram. Okay, so we are passing the test, which is very good. So let's commit. Or before we commit, we might check our implementation here. So let's try to copy and paste to the LeetCode. And I believe we can like run the test case. And if it is passing, then we can just submit it. Okay, we can submit it. Okay, we are passing, which is good. I think we can like commit here. This anagram returns true on anagram. Good. Now it's time to refactor because we have like green state, which is pretty good. Now it's time to refactor because we already have like green states here, I mean like green tasks. And I think that's a good idea to refactor because we are backed up by the test. So that's the power of TDD and the power of testing. Now we can like safely refactor it. I think we can like start from here, because I believe we can just return this statement here. Okay, so let's hit Command U again. Okay, we're still passing, so let's commit. Refactor by inline the if else statement. Okay, what else we can do here? This kind of repeated, right? So we can like create some kind of helper for that. So what I want to do is basically I want the first hash table is equal to hash table for the first string, and the second hash table as well. Second hash table is the hash table for the second string, and I believe that should do it. There. So we can create the helper. So let's create a function for the string. Return a hash table of character into integer. I believe we could copy the implementation here for the string, for every single character in the string. I believe we could neutralize this variable, hash table, and hash table, and we could like create the hash table, which is the character into integer here, and we can return the hash table here. Okay, I believe that should do it, and let's try to run again. Command U. Okay, we are passing, and now it's telling us that we need to change to let instead. So hit Command U again. Okay, that's great. Let's commit here. Refactor hash table creation using factory method. Vector hash table creation using shared factory method. Hit commit, and what else can we do? I believe it is not a good idea to name this as NT, so let's improve the naming here. Maybe we can like click and Control Shift on every single this one, and maybe this is the first string and this one is the second string. Click and Control Shift second string here. Hit Command U again, and good, we are good to go. Refactor arguments, commit. And what else can we do? Maybe we can inline this one. So hash table for the first string and the hash table for the second string. And I believe that should do it. So hit Command U again, and good, we are ready to refactor our code back up with a test. So let's commit again. Inline hash table comparison. So now we already have some kind of improvement here. So I believe we can like just again copy and paste things around, and let's see if we can improve this code. I mean, like for the sake of readability. So let's replace here. We can like mark this as helper. Okay, let's run again. Okay, we are good, and let's submit it again. Okay, so we are passing basically. So guys, that's okay guys, I think that's it. This is how we can solve valid anagram problem using TDD, and I believe you have seen the benefit of TDD in this video. It helps us to quickly validate our edge cases and helps us to, for example, find the breaking task while we creating new feature here. So I think that's all, and hit like and subscribe, and see you in the next video. Goodbye.